Hi students, this is Mr. Yao. Today we are going to learn more about angles with secants, tangents, and chords. First, a little bit of prior knowledge. We didn't exactly learn this, but you have seen these. How can we have intersecting lines with circles? First one, when the line is on the circle. And this is the one we have learned because this angle right here is going to be called the inscribed angle and is half of this arc that is facing. But today's lesson, we are going to learn the other two situations. One is the intersection is actually inside the circle, and the other one is the intersection that is outside the circle. You will notice we will still involve the number 1/2, and we will still involve the arcs that's being generated by the angle. So let's look at the first one, angles inside the circle theorem. If two chords intersect inside a circle, which means you have this intersection point inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arc intercepted by the angle and its vertical angle. Ooh, that is a long sentence. So let's take it apart and see what it means. Then the measure of each angle. Let's look at angle 1 first. That's angle 1, and we do have the vertical angle, which is the same as angle 1. What this whole thing is saying is that angle is going to be 1/2 of the sum. What sum? The sum is going to be these two arcs add together. Because these chords, if we extend them, is going to generate these two arcs that basically the angles are facing. So if you add these two arcs together and do half of it, that's going to be this angle right here. Same idea for angle 2. Angle 2 is facing this angle, this arc, and its vertical angle is facing that arc. So we are going to add these two arcs together and do 1/2 of it. That's why you can see right here, angle 1 is half of arc CD and arc AB added together. Angle 2 is half of arc AD and arc BC added together. So that's when angles are inside the circle. As you may notice, again, we are involving the number 1/2. And we are also involving the arcs that's being generated by the angles that we're focusing on. In other words, the arcs that the angles are facing. Now, what if angles are outside the circle? If a tangent and a secant, or two tangents, well, a tangent and a secant here, or two tangents, or two secants are intersecting outside a circle, then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arc. So whenever we have two lines, it doesn't matter if it's tangent or secant, as long as they're going through the circle, we will be generating two arcs, and two arcs that we are focusing on that's being intercepted by these two lines. And again, we are involving the number 1/2. Just when it's inside the circle, you need to add the two arcs. In this case, when it's outside the circle, you need to subtract two arcs. And of course, you're going to use the bigger arc minus the smaller arc. So we are still having a positive answer for the angle. You can't have a negative angle. So now if we put everything together, if the point is on the circle, well, you only have one intercepted arc. It's going to be 1/2 of that arc. If the angle, the angle is inside the circle, well, you have two arcs that's being generated, then you add the two arcs. Now in this case, if the point or angle is outside the circle, you are going to subtract the two arcs and then do 1/2. For all three of these situations, you are going to do 1/2 of the arcs. Now let's have a look at some examples. Example 1. X is facing 156 degrees and its vertical angle is facing 130. So all we need to do is add them together, 130 plus 156, and do half of it. So that means my x is going to be 1/2 of 286, which is 143. You may notice I didn't write the degree symbol, well, because the question is giving you x degrees, so we don't need a degree symbol for x. Question 2. X is right here, and you can see it's outside the circle, and the two arcs being generated are right here. So that means I'm going to subtract them. 178 minus 76. With a 1/2 in the front. So x is going to be 1/2 of 102, which is 51. That's example 2. Example 3. Y is here, and this arc is also given, but you are not exactly given the angle that's facing them, because this is the one that's facing these two arcs. But we're giving the one that's next to it, that is supplementary to it. So we can use 180 minus 102. We would know this angle right here is going to be 78 degrees. And 78 degrees is going to be a half of these two arcs added together. As you may notice, I'm not setting up to solve for y yet. I'm just setting up based on the theorem, based on what I know. 78 is half of y plus 95. Now it's time to solve. You can choose to distribute first to solve, or because of multiplication, you can choose to get rid of the 1/2. So multiply both sides by a 2 first. So 156 equals y plus 95. Subtract 95 on both sides, y would be 61. That is example 3. And it seems on your notes there's some mistakes that I made. So you don't have these next two examples. So you can choose to pause on the question and try them here, and then come back to the video and check your answers. So next, example 4. The angle is outside the circle, 55. So I'm just going to be doing the same thing, setting them up with the theorem. So it's going to be a half of the bigger arc, which is right here, TQ, which is the question mark, minus the smaller arc, which is right here, which is 45 degrees. Same thing, multiply both sides by a 2. 110 equals to question mark minus 45 degrees. So add both sides by a 45. That means my question mark is going to be 155 degrees. That is example 4. Example 5. Angle is outside, so that angle is going to be a half of bigger arc minus smaller arc. Bigger arc is 167 degrees. Smaller arc is a question mark. So multiply both sides by a 2. 76 equals 167 minus the question mark. So this time, if I want to solve for the question mark, I'm going to actually make it into a positive first. So you can choose to subtract 167, then get rid of the negative sign. Or you can choose to just move that question mark on both sides. Move that to the left side. 76 plus the question mark is 167. Now subtract 76 on both sides. The question mark itself would be 89. I kept forgetting the degree symbol. They all have degree symbols. Now we're good. That's example 5. Now example 6 is being labeled on your notes as example 5, so let's talk about it. Angle is outside the circle, so 34 degrees equals to a half of bigger arc minus smaller arc. One thing I need to emphasize on is when you represent these angles, you would need to include the parentheses, especially when you're subtracting them. So I'm going to keep the 3x minus 2 inside parentheses minus the x plus 6 inside parentheses. So next, multiply both sides by a 2. That means my 68 is going to be on the left side. Right side, I'm going to open the parentheses, 3x minus 2 minus x. That negative sign is also going to be given to the positive 6, so minus 6. Next, I can combine like terms on the right side. 3x minus x is 2x. Negative 2, negative 6 is negative 8. Add an 8 on both sides. 76 equals to 2x. So x is going to be 38. That's example 6. Next, example 7. Now this one is a little bit different. You are still given the angle on the outside. TSR is 69 degrees. We know this arc right here. However, even though we know it's going to be the bigger arc minus a smaller arc, currently we do not have a representation of the bigger arc, which is right here. However, because these are some tangent lines, and that's just 2 points, you may notice that these two arcs together make up the whole circle, which is 360 degrees. So I know I know one arc. I can use 360 degree minus that one to get the other one. So now I can represent the other arc as 360 minus 21x plus 6 inside parentheses because I'm subtracting them together. I can simplify that, 360 degree minus 21x minus 6, which becomes 354 minus 21x. There we go, that's my other arc. Now I can reuse the theorem. 69 degree is the same as 1/2 of the bigger arc, which is 354 minus 21x inside parentheses, then minus the smaller arc, which is 21x plus 6. Now it's time to simplify. So multiply both sides by 2. That is going to be 138 equals, let's get rid of the parentheses, 354 minus 21x minus another 21x, then minus a 6. So 138 equals to 348 minus 42x. I'm going to subtract 348 on both sides. That's going to give me a negative 210 on the left side and a negative 42x on the right side. Divide both sides by the negative 42, x would be a 5. And that is the last example. That is everything for 6.3b. Thank you.